these problems are the same. They're the same as the previous two sections. The difference is you don't know if your final answer is the correct answer because they don't have a list of answers. So what's your goal? Your goal is to try to simplify it down to be as simple as possible. That's your goal. Most of the time, you're probably going to be able to get it down to one trig function. Just like, look at the answers of the for previous two sections. You see all the answers are mostly like 1 or sine x, or that stuff. Okay, that's what you're trying to get. You're trying to simplify it down to that. Now, for each of these, you have different strategies, okay? Like this one, I'm gonna either change one of them or both of them, okay? And you sub in something for them, okay? Like you could use the quotient identity for the cotangent and use the reciprocal identity for the secant, and then you multiply. You'll see it. Once you take them out and write it, you'll see it. Over here, I see squared. Whenever I see squared, I think of the Pythagorean identity right away. Can I use the Pythagorean identity to make these look more simple? Okay, like this 1 minus sine squared x, that equals cosine squared x. And if I put cosine squared x in here, that might be easier to deal with, okay? Try to do things that will make it look a little bit more simple. I know there's 2 right here. You're dividing, which kind of looks scary. But look, what identity are you thinking of when you see the top and the bottom right here? The Pythagorean identities. Exactly. So I would use the Pythagorean identities right here. And don't forget, when you guys divide, that's the same as multiplying by the reciprocal. So if there's a fraction on the top, fraction on the bottom, that might help you out. Like this one. Look at this one. It says sine alpha divided by tangent alpha. We're dividing here. And if I use that one strategy that I was talking about earlier, and that is making everything sine and cosine, look how the problem changes. So if you have no idea what to do, like you're looking at it like, I just lost, you start crying and stuff, just change everything to cosine and sine, and then things might look better. Okay, and tangent is sine alpha over cosine alpha, right? Okay, so now everything is sine and cosine. It looks like I actually wanted to do this. I wanted to go sine alpha times the reciprocal of this. That's what I wanted to do. But now that I'm looking at it, I'm going, wait a second. And that's what happens a lot. When you actually write stuff, you see things better. If you multiply straight across, what's going to happen? I'm going to get sine alpha on top. And what do I get right underneath that? Yeah, because this would go under 1, right? And these cosines would cancel out. Oh, so pretty. Okay, and what is sine alpha divided by sine alpha? Uno. All right, so that's simplified to uno. Whoa. Now, is that the only way to do it? Guys, I can think of 3 other ways to do this problem. Whoa. Okay, so there's lots of pathways. You just got to make sure you don't break any trig rules or any trig laws. Don't break the rules. All right, so what kind of identity would this one be related to? Co-function identity. Co-function identity. So if you're not sure what that is, you got to look it up. I can't tell you everything. This guy right here. Oh, snap. I have a 1 minus sine. That is not a Pythagorean identity. Even though you would think it was because you see the 1 minus. You're like, oh, yay, Pythagorean. And then you're like, wait a second. It's not squared. So you can't do it. This one up here, ooh, that one's a Pythagorean identity. Oh, so in this case, I'm going to make this look dirtier. No, don't make it look dirty. Sorry, we got it, guys. Just hold on to your butts. Here we go. What is that top one going to be? It's going to be 1 minus sine squared y. And the bottom, ooh, I definitely want to do this one with you guys because we have factoring. Do you guys remember difference of squares? Yes, no? Here's an example. Here, x, we'll say 4x squared minus 25. Perfect square, and there's a difference, right? They're both perfect squares, and there's a difference. How can I factor what I just wrote right here? What is that? There's 2 binomials. Did you guys say 2x minus 5 and 2x plus 5? Okay, so if that made sense to you, then you should look at this with that lens on. Look at this guy. Perfect square, subtraction. So we have a difference, and there's 2 perfect squares. So we got business. We got 1 plus sine y, and then we got 1 minus sine y divided by 1 minus sine y, and then we get to cross stuff out. He's dead. And I'm left with 1 plus sine y. Is there anything else I can do? Nadag. Just leave it.